the ramp is at an angle theta. So we align the x-axis with the ramp because, well, it can make things convenient if an object is moving up the ramp, right? Because then the motion of the object just becomes the x component. We have to look at whatever is the x component that will just give us the result. But we may have to resolve other vectors along x and y to work with those components. So we'll see an example here that will give us the idea how to use it. So we have this mountain slope. So this distance along the slope is 360 meters. And then the vertical drop is 170 meters. And the skier is starting here, and they're starting from rest. They're just moving under gravity. And the fastest possible speed they can get is if there is no friction, there is no resistance of air, there is nothing blocking the motion, then it is the fastest speed you can get. So we want to know what is the fastest possible speed here. And the gravity acts vertically downwards. Right? So this angle is theta, and I can take at any point on this slope. So I'll draw it again here. So that is y, and that is x, correct? Let's say this is where the skier is. And then the gravity, acceleration due to gravity is acting vertically downwards. And 90 minus theta, because this is horizontal and this is vertical. So this angle is 90 minus theta. Also, we may not need it, but I'm just drawing the picture. And so if this vector is g is the acceleration due to gravity, we can resolve it along the x and y axis, right? Those will be its components. So there's a component here, and there's a component there. So that is g sub x is there, and g sub y is this vector. So the motion is down the ramp. There is no motion perpendicular to the ramp, right? So the only acceleration in place g sub x, and because the skier is not going into the mountain, it is moving moving along the slope, right? So gx, then if gx is the motion along the slope, then it kind of becomes motion in one dimension, because then we're just talking about the x-axis. So what is the magnitude of g sub x? So you can also notice, since this was 90 minus theta, this is also theta. G sine theta. G is the magnitude of that. Right? Since we've already drawn the directions correctly, we just have to focus on the magnitude. So g sub x is g sine theta. And now it is just motion along the slope. We can see, and we know that this is the x direction, so we'll only write the things for the x component. So what is Vx initial is 0 because starting from rest. And the position, since we can put the origin here for the axis, x initial is 0. And what is the final velocity? That's what we're trying to find out, assuming no friction. And what is the final position? The ramp is the x-axis. 360. This length is 360, right? We're measuring from the top. We put the origin on the top, and this is 360 meters down along the slope. The x-axis is along the slope. This is why we put the axis like this. So this becomes straightforward. And then the acceleration is g sub x, which is g sine theta, right? It's the acceleration is pulling the skier down the slope, right? But only the x component. The y component is pulling the skier into the mountain, right? But the skier will not be pushed into the mountain because the mountain will push back. That will study the Newton's laws of motion. But as you can see, the skier is only moving along the slope, and the acceleration along the slope is the x component of g. So now we can use our equations that we know. We know the delta x, right? Delta x is x final minus x initial, which is 360. Acceleration is gx, sorry, yeah, gx, which is g sine theta. And we need to find an initial is 0, and final we are trying to find out. So which equation are we going to use? So Vx final squared is Vx initial squared plus 2Ax delta x. So final is what we're trying to find out. So this stays as it is. 0 plus 2 g sine theta times 360. So what is sine theta here? 170 over 360, the opposite over hypotenuse, which is, you can cancel this. So this becomes 4 times 49 times 70. So Vx final is square root of that, so which is 14 root 17, right? So this is the fastest possible final velocity speed here, but the direction is given by that theta that the skier can achieve, assuming no resistance of any kind, no friction, no air drag, nothing. And the key ideas, if you look here, were that we aligned the axis, aligned the x-axis with the ramp, and then we took the x component of gravity as the acceleration along that. And it doesn't matter even if you took some other orientation of the axis, you should still get the same answer, but just you may have to do a little bit more work. So we have a 30-degree ramp, and the coasters are moving, or the car is moving up the ramp with an initial speed of 25 meters per second. And assuming no resistance, the only thing it is acting under is gravity. We want to know what is the final speed here. So again, we can place the axis here, right? So initial position is 0. Initial speed along x-axis is 25. We do know that it traveled for 2 seconds. So the time it takes to get to the top is 2 seconds. And we want to know what's the final speed at the top. Okay. X final, we do not know. We don't know, but that's not what we're after. We're really after. This is gravity acting downwards, and it will have components along the x-axis and the y-axis, right? But in this case, this x component is that way, because that will be down the hill, right? And so in this case, it is our negative direction of x. Since this is 30, that is 60, and this is 30. Gx, which is negative g sine 30 degrees, which is negative g over 2. Since we have the delta t, we can do the final equals initial plus. Now we can plug in, this is 25, this is negative g over 2, and that is 2. So the 2 cancels out. So this is 25 minus 9.8. This is the angle. What is the slope for the ramp? The trig ratios, what is their input? Angle. And what is the output? Output is ratio. The inverse will go in the opposite direction. This is rise and this is run. So slope is, what ratio is that for that theta? Tan theta. Given a ramp with an angle theta with the horizontal, its slope is tan theta, where we do this, take the theta in the standard way from the positive x-axis in the normal way, like the horizontal one. And so if theta is more than 90, then you'll start getting the negative slope. So if you want to increase the steepness, if you want to increase the slope to get the most acceleration, you're increasing theta, assuming theta stays between 0 and 90. Vertical will give you the max, right? A max acceleration, and the horizontal will give you 0, because then there is no x component.